Welcome to Q&A Wire.
To assist Jennifer in conducting a hypothesis test to determine if male smokers who suffer their first heart attack are on average 7 years younger than non-smoking males, we'd want to define the hypotheses, calculate the sample variances, decide which t-test to use, and perform the t-test. So the null hypothesis would be that the mean for smokers, the difference between mean of smokers and mean of non-smokers is -7. And the alternative hypothesis is that that difference is less than -7. Then we would calculate the sample variances from the first sample when we don't have the actual data, but you can calculate the variances as 1 over the sample size of that first sample of smokers minus 1 times the sum from 1 to, again, the number of the difference between the values and the mean squared. And from the second sample, and then you decide which t-test to use. To do that, if the sample variances are about equal, then we use a t-test, assuming equal variances. If they're significantly different, then you use a t-test assuming unequal variances. A common rule of thumb is to use the f-test to compare variances. If f is within an acceptable range, based on critical values from the f distribution with n1 minus 1 and n2 minus 1 degrees of freedom, we would assume equal variances. And then you perform the t-test, which would be the sample mean from the smokers minus the sample mean from the non-smokers minus -7 over the pooled standard deviation times the square root of 1 over the sample sizes. The pooled standard deviation is the square root of the smoker's sample size minus 1 times the smoker's standard variance plus the second sample size of non-smokers minus 1 times the standard deviation of the non-smoker squared, or the variance, over the sum of the sample sizes minus 2, which is the degrees of freedom. If it's unequal variances, then the t-test is the difference between the two means minus -7 over the square root of the variance squared over the sample size plus the variance squared, not the variance squared, but just the variance of the second sample over its sample size. But then the degrees of freedom would be calculated as the variance over the sample size, that sum squared over the square of the ratio of the variance to the sample size squared over the degrees of freedom from the smokers group. And then you have the non-smokers variance over sample size squared over degrees of freedom. And so you're just going to do all the substitutions here, and then you would decide based on the critical t value at the 5% level with 100, well, we don't know how many degrees of freedom there are, but you would find the degrees of freedom with the critical t for 5% from the t distribution to make your decision.